Hello, everyone. I'd like to have a brief introduction to our big data projects. Our team consists of three members: Ximing, Li Xiang, and Xuexin. And our objective is to give users some advice on their house price and the prediction accuracy, so that they could make a more accurate decision. And the house price prediction is based on the property of house. And we also dive into the relationship of prediction accuracy and the property of a house. In other ways, we dive into the degree of whether the house price is predictable. And we used several datasets and algorithms to predict the house price and its accuracy. We adopt zero house price data set and also two sigma stock price and news data. We also adopt the house price data, which is used to predict the house price. And the zero house price data is used for prediction accuracy of the house price. And we use many advanced and popular frameworks such as XGBoost, Scalar, and Light Gradient Boost. And those algorithms and tools have a superior performance when compared to some other tools such as Spark machine learning library. They are strong at the parallel computing and distributed system. This is an overview of our systems. We adopt Google Charts and also build a simple prediction form to input the property of house and so that we can get the house price prediction results and its deviation. And later we would have a short demonstration on our website. And please let me explain some of our data exploration process. And the exploration process helps us to choose the most important factors to train our models. And the left one is the correlation of heat map among those parameters. From this map, we can see the relationship between those parameters to show whether the two parameters have a strong relationship to each other. And the middle one is a graph shows the relationship between the built year and the house price. From those graphs, we can see a tendency of the house price range goes along with the built year. And it tends to be that as the house is built later, and their price would go up. And those small graphs shows us the variation of the parameters go with the other parameters. And from those graphs, we pick out some of the most important graphs and to have a more in-depth analysis. Those graphs are drawn by some classical visualization tools such as Cboolean, Matplotlib, and so on. You can also see from this graph that the overall quality have a strong influence to the price. When the overall quality goes up, and the price would goes up. And another very important process is to clean out the missing data. Because the missing data have a negative influence on our prediction accuracy. So we can see the poor data have a very large percentage of the missing. And this is our process of cleaning the data set. And we can draw a graph to show the missing data percentage. I also have a brief introduction to XGBoost algorithm. And this is a basic demonstration about our models. And we can see from this graph picked from the paper of XGBoost that we can see XGBoost have a superior performance when compared to Spark machine learning library.
Let me introduce the data exploration of the log error dataset. To analyze which properties have strong influence on the log error, we grouped the absolute log error into different percentiles. The top 10% as the best result, the worst 10% as the worst, and the 50% around the median as typical. If the three lines are coincident, these properties have less influence on the prediction. As we can see in the picture, longitude have strong influence and room number has less influence. We paint the location on the map. The color shows the log error of the house in this location. We can see the latitude and longitude have strong influence on the prediction of log error. So we need to include the longitude and latitude in our training model.
Here's our code of training the models, and here's the training result. We apply several models, and we also combine those models together so as to yield better training results. And they also did some data exploration about stock data, such as the first photograph is about the price of the Apple Incorporation and also the trading amount of the total assets. And here's our reference.
We do some more interactions with the user and also to visualize our data. And we pick out some of the most important factors that would influence our results. And we also deploy our training models into the clouds and our web applications so that the users can input their parameters and get the results. And like the first one, we can see as the total basement square feet goes up, the sale price would go up naturally. There's a strong influence to each other. And also when it comes to the second picture, we can see the median and the mean of the sales price fluctuates, and with the overall quality. As the overall quality goes up, there's a strong tendency that the sales price will go up. And we can also see the fluctuation among the built year and the density of the built houses. We can see that's around 1960, the house build density the greatest. And also the fourth picture, we show the year of sold and the lot area, and also the sale price. We can see that the year sold goes up, the house price would go up, and when the lot area goes up, the house price would be increasing. When color that is darker, that represents the higher price. And also for our prediction and advice model, we input some of our key parameters that we choose from lots of parameters of the house. We first input the overall quality, years of build, and basement area, and the room count, like 3 total square, total area, and lot area, garage area, pool area, perhaps no pool, right? And the full bus 2, half bus 1, garage cars 2, fireplace 5, first floor like 1,000. We submit it, and we can see the prediction of our price is around $316,000. And this house price data set is gathered from a certain place, not the entire country. So this price prediction is tied to a certain location, and this prediction means the predicted price at that place. And we can also show that's the deviation of our prediction, which shows that how accurate the house price prediction is, because the house prediction accuracy is also relative to the parameters we input. So we can show that how much the house would cost and how convincing our result would be.